Right, well, first of all, good evening from Albion Stone on Portland. Firstly, can I say many thanks for the invitation to make the presentation, albeit under the really strange circumstances that we find ourselves living through at the moment. Perhaps I should begin with a word of introduction about myself. My name's Mark Godden, and I've been working in the Portland stone industry for nearly 40 years. I'm currently employed as Albion Stone's mine manager, and I've been a member of the Institute for 28 years. Professionally, I'm a geologist, and I've been closely involved in the development of mining techniques on Portland since the idea was first conceived as a possible way forward for the local industry back in the late 1990s. I'm in no way claiming credit for what follows. The transition from quarrying to mining has only been made possible by a huge team effort involving many people. In this talk, I'd like to touch on the following areas if I can. I'll begin with an outline of Portland's geology, take a brief look at how and why Portland's stone industry developed as it did, consider why it became necessary to make the radical change from open cast quarrying to underground mining. I'll talk a little bit about how Jordan's mine was started and a few of the lessons that we learned as mining proceeded. And I'll finish up with a few words about where Albion Stone is today and where we hope that it's going to. A short presentation such as this can't hope to cover every aspect of the story being told, so instead, I'll attempt to give an overview because the details could easily fill a few books. If requested, I'll be happy to try and add some detail in my answers to any questions at the end. So we'll start with the geology because that's my bit. Portland limestone is an oolite, meaning that it's composed of countless billions of tiny calcareous spheres called ooliths or ooids, which have become cemented together through geological time. It's one of the youngest Jurassic rocks in Dorset at approximately 145 million years old, and was laid down in a shallow and warm marine environment under subtropical conditions in a position far south of where Portland is located today. Portland limestone beds are tectonically unmolested and therefore tend to yield large blocks of building stone with few open fractures. Portland stone occurs in thick beds of a uniform white colour, making it highly desirable for architectural use. Within limits, it can be cut and carved in any direction, making it pretty much a freestone. It's also quite a user-friendly rock, being sufficiently strong to resist the weather for a very long time when used in a building, but still relatively easy to cut and carve in its raw state. Portland is a tide island joined to the rest of Dorset's coastline by the sweeping tombolo of Chesil Beach. To many of us who live here, it's also somewhat of an earthly paradise, but I would say that because I'm a Portlander. The Jurassic Age rocks on Portland all dip gently to the southeast and form the southern limb of the Weymouth anticline. Stratigraphically, the Portland limestone is sandwiched between the slightly older Kimmeridge clay, which underlies it, and the slightly younger basal purbeck beds, which overlie it, and thus form the upper surface of the island. Traditionally, the basal purbeck beds would need to be cleared as overburden in advance of open cast quarrying, whereas with mining they remain undisturbed. Portland stone was exploited by the Romans and used for the first stone bridge over the Thames in the 1300s. We know the Romans used the stone because of a very large number of Roman sarcophagi that have been unearthed on the island over the years. It was used in London for the first stone bridge over the Thames in the 1300s, as well as for parts of Exeter Cathedral and Christchurch Priory. Stone quarrying on Portland would have been pretty much a cottage industry throughout the Middle Ages. Inigo Jones and Christopher Wren really kick-started the dimension stone quarrying industry on Portland on an industrial scale in the late 1600s because the stone was needed in London. Ancient joint control landlords along Portland's northeastern coast put huge quantities of dimension stone on the beaches for easy exploitation by 17th century quarrymen. The photograph shows part of the Southwell landslip, which remains Britain's second largest recorded landslide, when in 1733, a 2.4 kilometre long section of coast was spectacularly displaced. Much of the dislodged limestone was subsequently quarried away. Interestingly, it's quite possible that earlier quarrying activity actually contributed to the causes of the Southwell landslip, literally by undermining the stone. Before the late 1600s, the quarrying of dimension stone on Portland was carried out exclusively at coastal exposures. As previously mentioned, quarrying would have then been a fairly small industry. At this time, the island was probably much better known for the delicate flavour of its indigenous mutton than for its stone. Proximity to the sea facilitated the loading of stone blocks onto barges for transportation along the south coast and up the Thames into the heart of London. This fisherman's crane, pictured at Durdle, photographed over 10 years ago, was sighted on the east coast of Portland and was Victorian in age. The crane has now sadly been washed away in winter storms, but this would most certainly have been a very early stone loading site. In 1619, Inigo Jones used Portland stone to build the banqueting house in London's Whitehall, which proved its suitability for use in classic architecture, of which Jones was a very keen student. On the 3rd of September 1666, at 2 o'clock in the morning, Thomas Fariner, an unfortunate baker working in Pudding Lane, with culinary skills that appear to be scarily comparable to mine, set London on fire. The Great Fire would not only completely alter the face of London with the loss of the old St. Paul's Cathedral, 13,200 houses, 87 parish churches, 52 livery halls, and Newgate Prison and the Guildhall, that would also change the face of Portland forever. Following London's fire, the need for an incombustible material for rebuilding eventually led Christopher Wren to Portland. Wren's relationship with the Portland quarrymen was fractious, to say the least. Problems related to royalty payments for stones raised from the island's crown common lands, of which the commoners traditionally received a share, at one point erupted into open mutiny by quarrymen. Despite these ongoing local problems, Wren used Portland stone to rebuild St. Paul's Cathedral and many of the other churches destroyed by the fire. Besides Portland stone, several other British stone types were originally incorporated into the fabric of St. Paul's, particularly Burford stone, a brown iron-rich limestone from Oxfordshire, which gave the new cathedral a two-toned appearance. They say that every cloud has a silver lining, and unfortunately, or fortunately for Portland, the Burford stone did not weather well in the polluted city environment, and by 1766, it had been entirely replaced by Portland stone. Incidentally, the Houses of Parliament are currently suffering similar issues with the magnesian limestone from Anston Quarry in Yorkshire, a building stone which has also not stood the test of time in a polluted environment. Successful use following the fire helped to firmly establish the use of Portland stone within London, and led to the ongoing construction from it of many of famous buildings and monuments that we can see today. And London is still Portland's main place of use, Portland stone's main place of use for both new build and restoration. This drawing by Grimm from the late 1700s shows stone being quarried at Church Oak Cove on Portland's east coast, with the ruins of Rufus Castle in the background. By this time, the stone industry had become much more economically important to Portland and would have been employing a good proportion of the working population. Over time, quarrying began to move inland as the easily accessed coastal exposures became exhausted. This often involved the use of horses in what we would today consider to be unacceptably cruel conditions. An account written in 1804 by Francis Webb, a visitor to Portland, described how horses were being used to break stone wagons going downhill to the port. Webb wrote, "Horses were squatted down on their haunches and suffered themselves to be dragged for many hundreds of yards, struggling with all their strength against the weight which forces them forwards." If you want to know what that looks like, look at the two horses to the left of Grimm's drawing. You can see them restraining the load. Less cruel methods of transportation were eventually developed, including a very early gravitational-powered cable railway system with a gauge of 4 feet 6 inches. Built in 1826, the Merchants' Railway, as it became known, was used to efficiently move blocks of Portland stone from the quarries at the top of the island down to the port for subsequent transportation by sea. The railway was Dorset's earliest, and it remained operational until 1939, when competition from diesel lorries and road transportation finally rendered it uneconomic. Open cast quarrying, using hand-powered and then steam-powered derrick cranes, boomed during the Victorian period. The industry remained busy throughout most of the 20th century. Huge quantities of Portland stone were used for monuments and headstones following the First World War, and to repair or replace bomb-damaged buildings in many towns and cities following the Second World War. Brutalist architectural trends favouring the use of concrete and glass during the 1960s and 70s caused the Portland stone industry to contract to the point where there were only a handful of people employed in the quarries during the 1970s. Fortunately, there was a return to more classic building styles during the 1980s, and this led to an increased demand for high-quality building stone, which effectively reignited the quarrying industry on Portland. Interestingly, the small hand crane to the left of this photograph still exists. It now sits at the top of the hill on Portland as a monument to the stone industry, where it overlooks Chesil Beach. Quarries can take up a lot of room. This is a particular issue when the beds being won are relatively thin, meaning that rapid lateral spreading is inevitable. The photograph shows the Immerstake area of Portland. Piecemeal quarrying began here originally in about 1828 and ended a few years ago when Albion Stone extracted the last remaining reserves of dimension stone on the site. Jordan's mine was started in 2008 beneath the cricket field, which can be seen in the bottom left of the image, the flat area. A great deal of the area shown in the photograph has now been designated as SSSI. Quarries often have an amazing ability to transform themselves into niche environments full of unusual flora and fauna, and that's what happened here, with virtually no human involvement at all. So what drove the change from open cast quarrying to underground mining? Well, there are a number of factors. The first of which really is Portland's geographical size. It's only 8 square kilometres. The island's got a relatively large population for such a small area of about 12,700 people. Many of the existing unquarried areas are legally protected as SSSIs and SACs, and these things now combine to mean that there's very limited potential for new greenfield quarries on the island. Chances of getting planning permission to dig a greenfield quarry on Portland are about 0, I would say. It was realised back in the late 1990s that mining could potentially provide access to significant remaining reserves of dimension stone with few environmental impacts. Portland stone is still in high demand, particularly in London. Weymouth and Portland are economically depressed areas with, according to a government report published at the end of 2018, the lowest social mobility amongst young people in the whole of England, which is a shocking statistic. The stone industry provides much needed local employment and therefore is very important economically to the area. Before any mining could take place on Portland, the general public, the mineral planners, had to be convinced that the underground extraction of Portland stone could be carried out safely, and there were no threats to either the people involved, members of the public, or the overlying land surface. Following a protracted period of preparation and working in conjunction with Albion Stone's planning consultants, Wardle Armstrong, a small trial mine was developed in Bowers Quarry during 2002. The valuable lessons learned in the trial mine were used in the planning and commencement of Jordan's mine a few years later. Jordan's mine was to be a full-scale production mine, taking the lessons learned by Albion Stone during earlier experimental phases forward into what has since become an economically successful operation thanks to the efforts of many people over a long period. Mining methods have been subject to continuous refinement since Jordan's mine began operating towards the end of 2008. The old faces in Jordan's quarry were identified as being suitable and were prepared for mining in September 2008. The orientation of the local jointing pattern worked well at this site. Because it had been quarried, the quarrymen worked with the joints that pre-existed. They stopped probably because of land ownership issues, but the orientation of the faces were pretty spot on for us. Once the faces had been made flat, the exact positions of the new portals were accurately painted onto them. I remember actually doing that. The overlying capstone beds were reinforced with horizontal rib bolts, and then a Fantini mining machine was used to cut the first mining machine advance. The cut face was displaced using inflatable steel pillows called hydrobags. These are 1 metre square and they produce enormous forces when pressurised with water. These forces can then be used to loosen and shear the stones to the point where they can be removed. And on this image, it's possible to see 4 hydrobags in the topmost cut. So we've worked with gravity in this instance. And the stones have been all pushed downwards and sheared off on their rear faces. The first blocks from Jordan's mine were then extracted using a Komatsu WA600 loading shovel that was normally employed in the quarry. Much too big to fit in the hole, but good for taking out the first blocks. The mining machine was oscillated between the two new mine portals. Whilst one portal was being cut, the other was being cleared of stone and prepared for cutting. In this way, progress was fairly rapid, and two new mine tunnels were evident within a week or two. Roof support was installed as the tunnels were deepened. 2.4 metre long resin encapsulated rock bolts were installed vertically upwards to reinforce the roof beam. The roof was also monitored closely for movement, and such monitoring is still being undertaken even now. This area of roof in the picture is still being monitored. The graph shows the roof to floor convergence over time for the area of roof that we've just seen. The period covered is from the time that the portal was first cut in 2008 until now. Net measured movement is only around 2.5 millimetres. Jordan's mine is a really stable mine. Meshed steel frames designed to prevent any loose material from the face above falling and causing injury were installed around the new mine portals. Subsequently, secure gates were fitted to these frames to prevent unauthorised access to the new mine. Progress within the initial two roadways was soon sufficient to allow the first crosscut to be made, linking the entrance tunnels together. Roadways and pillars are all designed around a notional 6.5 metre times 6.5 metre grid. This leads to a maximum aerial extraction ratio of 75%, meaning that a minimum of 25% of the available rock is left behind in the form of roof supporting pillars. By the 27th of January 2009, the first freestanding pillar had been created. I remember that felt like quite an occasion at the time. For the first 2 years, mining only took place on the uppermost whitbed seam of Portland stone. We've got two mining machines in the image working together with a pillar between them. By December 2012, work had begun to create a 10-degree decline cut into the original mine floor to provide eventual access to the lower basebed seam by creating a vertical face in it. Over time, more Fantini GU50 mining machines were acquired by Albion Stone, which accelerated the growth of the mine. The company now has a total of 6 mining machines in operation. By July 2014, 2 basebed access ramps were complete, and this bed of valuable stone was being routinely extracted. The ramp effectively lowered the mine's floor by 4.5 metres, resulting in roadways with a roof-to-floor height of 9.5 metres. The yellow duct in the picture is for air, and at this time, a forcing fan located just outside one of the mine portals blew air through the ducting to the deepest part of the mine. A Fantini mining machine was used to make vertical and horizontal cuts in the newly created basebed faces. Hydro bags were then used to displace the stone before it could be removed using a forklift. The original floor level can be seen next to the mining machine in the photograph, so we've got 2 different floor levels going on here, basically. 5-ton sloughs were and still are used to trim faces and clear rubble in advance of recutting. This is in the picture is a Hitachi mining machine, a Hitachi slough, sorry. We now have a small fleet of Volvo EC55 machines with air-conditioned cabs doing this work, slightly better machines. Initially, roof bolting was undertaken using a relatively simple Marini drilling rig, which was originally designed for use in a quarry, but which the manufacturer was able to modify by inverting its boom to make it drill upwards. The machine had several undesirable issues. Moving it from face to face was laborious. Bolting involved the use of a ladder to insert resin in a hole, which is working at height, which is not great. And most problematic of all, the operator needed to be positioned beneath or almost beneath the ground being supported, which for obvious reasons was not ideal. The Marini bolting rig was also used to install horizontal rib bolts into pillars to support them in advance of lowering the floor. The rib bolts are designed to prevent joint-controlled delamination from a 9.5 metre high pillar when access would be difficult. So we solved the problem before it starts, basically. By mid-2015, a great deal of basebed had been removed from the mine's original permitted area. Roof-to-floor height in the image is about 9.5 metres, and the field of view is 50 metres or more. So it's a big old space underground. Note how the dilated joint visible in the top of the photograph has been kept within the pillar and not in the roadway. And this is the most stable configuration. It's something that we would normally aim to do, keep the joints in the pillars. Work on the whip-head horizon continued in parallel with base bed extraction in newly permitted extensions to the original mine, which were gained following a number of additional planning applications. By this mechanism, the size of Jordan's mine has gradually increased through time. Another operation called Bowers Mine, situated close by, was also started beneath some playing fields. This will ultimately become merged with Jordan's mine as both operations expand laterally towards each other. Throughout the mine's life, many tweaks and refinements have been incrementally made to working methods, with the aim of increasing efficiency and reducing costs. Mining at Jordan's originally began using a 16-ton Manitou telescopic handler. The Manitou telehandler was eventually replaced with a Volvo L150H loading shovel, fitted with a bespoke lowered cab. This machine proved to be more suited to the application and to the environment, so the old Manitou was retired from underground and is now used for other less demanding tasks at the surface. This machine is also fitted with forks, so it's great for block handling. It proved necessary to remove an uneconomic bed of limestone and chert called kerf, which overlies the base bed, before the base bed could be efficiently bench mined. Removal of the kerf was initially undertaken using hydraulic breakers, but this ended up being a relatively slow and noisy activity, quite onerous, dusty, not very nice really. Experiments using quarry bench saws to assist with the removal of the kerf bed by making 3-metre deep vertical cuts into the mine floor was carried out in an effort to improve the process, and these trials proved really successful. By around 2016, all of Albion Stone's quarrying reserves were exhausted, and the bench saws, which were previously used in the open cast quarries, were introduced into the mine to assist with kerf and base bed removal. The operation is designed to detach the rock in the floor from the pillars, so that when the floor is removed, we don't disturb the pillars. And this made the use of the hydraulic breakers to complete this task unnecessary. In this photo, a mining machine is being used to undercut the kerf bed, the sides of which have been pre-cut using the bench saws. This bed will subsequently be displaced in block form using hydrobags. In 2018, after a great deal of research, a new Boltec S bolting rig was purchased from Epiroc in Sweden. This machine offered many advantages over the old Marini bolting rigs, not least that the operator does not have to stand beneath the ground being supported. The rig is a hybrid. It travels under the power of a diesel engine and drills using electricity, which helps to keep exhaust emissions down, particularly when working in blind headings, with very low output from the machine. Bolts can be installed by an operator safely housed within a soundproof Fox cab. Bolt installation times are very short, and no working at height is involved in the bolting process. The machine is also highly mobile. Believe it or not, this high-tech machine is even equipped with semi-automatic boot washing facility for those entering the cab. The new bolting machine makes the installation of high-density roof support at dilated roof joints much quicker and safer. The machine is fitted with a mesh handling arm to allow the remote placement of mesh sheets during the bolting process, so nobody's up in the air. In November 2019, the mine experienced its very own channel tunnel moment, when two roadways simultaneously driven outwards from the mine and inwards from the faces in Bowers Quarry met beneath a local churchyard. Work to create this link into Jordan's mine had taken many months, and the result for the mine was 2 additional exits. This led directly to improvements in efficiency because the haul distance from mine stone was dramatically reduced. The health and safety of mine employees was also enhanced because more means of emergency egress were available, and improvements in the way in which the mine is ventilated were also made possible. The trajectory of the mine tunnels had been set out nearly a year before when they finally joined up. After a very great deal of trepidation in the weeks before, there was a great deal of relief when everything lined up pretty much as planned. At the end of 2019, a new ventilation fan was installed into one of the original portals at Jordan's mine. This fan delivers up to 70 cubic metres of fresh air into the mine each second. The air exhausts via the new portals. Ventilation is used to flush diesel exhaust fumes and low concentrations of radon gas from the workings. The mine is surveyed each week and an updated mine plan is produced. Lasers are routinely used to set out mine roadways into new working areas. These help to maintain good mining geometry and maintain an adequate aerial extraction ratio. keeping the pillars the right size, basically, and the roadways. A Volvo L150 loading shovel can pick up and carry blocks of around 19 tonnes. This allows the mine to produce stone suitable for the manufacture of very large pieces of masonry. Blocks of stone are transported out of the mine where they're squared up and made ready for sale using JCB Fantini machines. This is basically a tractor with a very large blade on it. The blades are diamond tipped, they dry cut, there's no water involved, and the cutting technology is very similar to that used on the mining machines. So spare parts are all interchangeable, which is useful. The machines are very mobile, so a whole number of blocks can be laid out in a row, and the saw can travel from block to block, so it doesn't require the attention. This process doesn't require the attention of a loading shovel all the time. Albion Stone supplies Portland stone in several forms. Stone is sold in block form straight out of the mine. The company owns a modern factory close by, and from there, the company can supply cut stone either in the form of slab, sawn six sides, or as fully finished bespoke stone masonry ready for installation into new buildings and monuments. The mine now has a fleet of 3 Volvo L150 loading shovels and 6 Fantini mining machines, making it one of the UK's most productive dimension stone mines, producing several thousand cubic metres of high-quality dimension stone annually. The extent to which Jordan's and Bowers mine have so far been developed, covering an area of around 7 hectares or 17 acres, can be seen as an overlay on this image in red. The total permitted area, including standoffs, is currently just over 15 hectares or 37 acres, which contains at least another 10 years' worth of mining at current extraction rates. The stone recovered from these areas could never have been accessed by traditional quarrying due to the close proximity of housing and other sensitive environmental receptors. You can see on the image houses all around us, and we can carry on fairly freely with no complaints really, which is great news. Albion Stone has secured an additional 60 acres of permitted mining reserves beneath agricultural land at Stones Hill on Portland. The site is currently being made ready for mining in the future. The decline has already been cut down through the basal purbeck beds to the top of the dimension stone beds. The dimension stone beds will be conventionally quarried away to create the vertical faces into which mine portals will eventually be cut. Early indications are that the stone here is of a very good quality, which bodes well for the future of mining in this area of Portland. It's anticipated that once it's established, Stones Hill Mine will be yielding dimension stone for many decades to come, thus helping to ensure a continued future for Albion Stone, for Portland's historic stone industry, and for those employed within it. And that's the end. I wonder if there's any questions.
Hi, Mark. Really enjoyed that. Couple of questions, really. Does every section of roof have to be supported with the rock bolts, or do you only put them in as required?
No, the roof is systematically supported. We took the view initially that we would take that judgment out of it and we just systematically support the roof. So for every mine machine advance we make, we put in bolts.
Okay, thanks. And you mentioned that when you get the joints, you try and map them into the supporting columns. Do you have to have pretty good kind of advanced awareness of where those joints are, or do you have to adapt the mine plan? On the mine plan, I pick them up and we actually map the joints. They're very linear, they're quite predictable, and we're able to quite successfully project the strike of the joints forward, so we know pretty much when we're going to hit them. Oh, fascinating, thanks.
Mark, I think you said in your presentation you were having a 75% yield.
No.
How does that compare to when you were doing open cast, basic quarrying?
Well, the aerial extraction ratio is 75%, which means that we take out 3/4 of the area and we must leave a quarter behind in the form of pillars.
Yeah.
But as I mentioned, we tend to leave the more fractured stone within the pillars, which we know it tends to be of poorer quality. In terms of yield, the yield in the mine is slightly better than the yield we recovered, we used to get in the quarry, because the extraction methods are a little bit more precise.
Thank you.
Mark, I actually had an email prior to the presentation with a question from somebody who hasn't actually made it to the meeting, but I'll ask the question anyway. Basically, it said, for those whose homes are located over coal mines, subsidence is a common problem. Is there potential for the Portland Stone mine to cause surface subsidence? And if so, what preventative or remedial measures are taken?
Absolutely not. We're only mining under open ground. We're not under any occupied land. There's no houses above the mine. And coal mines are designed to collapse as they progress. Our mine is designed to be stable in perpetuity. It will be stable forever.
Thank you.
Any more questions? I'm surprised.
Mark,
A couple of people I know have worked at Portland Stone in their past careers. I'm surprised.
Mark, hi. Fantastic presentation, Mark. That was mind-blowing, some of those pictures. I was involved in Portland and in the Barstone mines. It was interesting to see how you calculated your pillars and your roadway widths. Presumably that was a fairly detailed scientific investigation to come up with that plan. Obviously, the Bath mines suffered with the pillars being robbed after they were initially built. So they had, as somebody mentioned earlier, particular problems in Bath with subsidence, which you're not going to have. How did you actually go about the sort of calculations?
The calculations were based on some very well-worn geotechnical formulas. There are some very well-used geotechnical principles that were applied. First of all, you look at the rock mass, you look at the number of joints in the rock mass, you look at how hard the rock mass is, you plug those figures into some fairly well-used formulas, and they kind of spit out the right answer, basically, Steve.
Interesting. Yeah.
And then obviously from then on in, it's you do it and you monitor and you prove the design.
Good.
Can you talk a little about your current production versus sales? Do you anticipate your sales in the future to go up, or is it a reasonably level?
Well, I mean, current times, God knows what's going to happen. At the moment, sales are holding their own, and fingers crossed that carries on. But with the COVID situation, if that begins to impact high-end building in London, then I wouldn't like to say. You know, at the moment, we've been fairly lucky.
But when you're obviously developing in this new mine, what I'm thinking about is, obviously, in the future, is there more development after this new mine? Is there another area that you could go to after that?
The new mine's probably got 60 years in it. I don't need to worry about that, really.
Okay.
We've probably got 60 years worth of reserves in the new mine, and that no one can look any further forward than that.
That's at current sales. But do you think sales will increase in the future as more and more repair work needs to be done to where buildings have had more impact from old Portland buildings that have require more maintenance?
Well, that tends to be a fairly steady market because things are subject to rolling restoration. Portland Stone's been in London for 300 years, and every now and again someone will decide to repair something.
Okay.
So it's a fairly flat, constant demand for restoration.
Mark, like Steve Cole, we go back a long time. I was remotely involved with Portland in so much that I worked for Kingston Minerals back in the late 60s. And as you say, that was a depressing time for Portland Stone. And that time they were trying to export the stuff. And I wonder, do you still export? Can you export Portland Stone to Europe? Is that part of your market or not?
We would export stone to anyone that would wish to buy it, and we certainly send some to the States. Certainly, some goes into Europe. Some even goes to Australia. But the main market is and always has been London. What's your relationship with the planners? Reading between the lines, it seems that you had some problems in years gone by with the local planning authority. Is that now a good relationship? I think we've got a respectful relationship. Yeah, I mean, to be honest, the planners were very supportive of the concept to mine. They much prefer the concept of mining than they did open cast quarrying, for obvious reasons.
Okay, thank you.
Just one more from me, Mark, if you don't mind. How was that experience of kind of going into the mining versus quarrying? I mean, did you develop a lot of knowledge and experience in-house, or did you have to bring in external people to kind of really drive that process?
Combination, really. Some people came to work here for a bit and showed us the ropes, and we kind of took over from there and ran with it, really. A good friend of mine came to work with us for a bit, and it's just kind of exploded from there, really. It's been an incredibly interesting, professionally, a very interesting thing to do.
No, I can imagine. Thanks.
It's Martin Isles. My apologies for late entry to this. I wondered if my question had got asked with regard to the possibilities of surface ground effects from the mining, and indeed as it might affect the new mine. Have you had any problems there? And if so, what have been the mitigations?
No, the mine is designed to be stable, Martin. It's not. We've never experienced any uncontrolled fall of ground within the mine. The mine is systematically supported and it's designed to be perpetually stable. We really we don't have any infrastructure. Certainly no housing above any of the mines. It's all tends to be open areas, but we really can't afford to create any surface instability, so we go all out to avoid that.
Okay, thank you.
Mark, if I may, that was an excellent presentation, very informative. But on a related issue, what are your planning conditions regards surface vibration? What are you allowed to generate at the surface, and what do you actually generate at the surface?
Very little. I think that the limit is 2 or 3 millimeters per second squared. But nothing that we do really, apart from maybe hydraulic braking could be potentially a problem. But nearly the whole process is vibration free, to be honest. The mining machines produce no vibration at all.
So do you think you might be able to make a case to say you can go under properties or residences?
The only reason we don't, or one of the reasons we don't, I won't say the only reason, is that it's land ownership. It's who owns the mineral, and in most cases, people in houses own the minerals beneath their house. So it's not a case of a geotechnical problem. It's land ownership really, and perception, of course, as well.
Okay, thank you very much.
Mark, Dave Payne here. Just one question, and thank you very much for a very good presentation. Just one question. After use, there's going to be a lot of holes in the ground where you've taken the stone out of. Any thoughts for the future use?
Well, certain parts of the mine, we're obligated under planning to backfill to the roof. That's just part of it. And other parts we've been looking, or Albion Stone has been looking at the potential for either storage or as there is a proposal on the table linked to the Eden project in Cornwall to turn some parts of the mine into a visitor attraction. But that needs to attract some funding, and the jury's out at the moment.
Okay, thank you very much.
No problem.
What in terms of the temperature in the mine, is it a consistent temperature in the mine?
Yeah, temperature's about 15 degrees most of the time. We do
all
blow
year round, yeah?
Yeah, we do blow a bit of air in, which does vary that. But if you go into the mine in the middle of winter, it's like someone's got the heating on. It's quite striking.
Okay.
There must be a bit of geothermal heat going on there. There really must.
Any further questions?
Just one more, if I may. What typical depth are you down, or what head of rock have you got above you typically?
From roof horizon to field, about 15 or 16 meters, depending on where you are in the mine. Somewhere between 15 and 16 meters.
Thank you.
Okay.
Can I just know, it's Terry last here. Mark, thank you for your presentation. Thoroughly enjoyed that. I can remember when base bed and whip bed were getting rarer on a quarry basis, that there was a push to use a lot more of the roach stone. Is there still roach in the sales portfolio that you've got? And
Absolutely.
Is that still quarried somewhere, or is there an eventual hope that you'll quarry the roach stone as well?
No, we take the roach. If you look at the picture with any questions written on it, I don't know if you can still see that, but the bit of stone near the yellow part is roach. So we take that.
Okay.
We definitely still produce it. It's one of my favourite stones. As a geologist, it's
it's been used very well. Paternoster Square, for example, it's an attractive use. So,
we supplied a lot of stone in Paternoster, and unfortunately, fashion is that stone containing shell is not very popular at the moment, but that's just down to aesthetics, really. I mean, a shelly stone tends to be a better performing stone, certainly, in hostile environments.
Thanks very much, Mark. I think it was over 3 years ago when I first talked to you about the possibility of you presenting a paper on this. You said you were quite busy at the time, and I think probably that was an understatement. So thank you very much for the presentation.
That's my pleasure, Steve.
I think there must be a lot of fairly envious geologists out there who would love to have been involved in that project. And it certainly seems to, from the days when I was down there last in the 1970s, when black powder was still the common means of getting the stone apart and things like that, to where you are today with your lasers and what have you, really brought it in the 21st century. I think it's been a fascinating paper. We've had over 80 people watching you this evening, Mark, which says something in itself. So thank you once again. I think we can all do a sort of silent clap for you if you like.
Sorry, Kyle. I'm sorry for the shaky start. I got my timings wrong, that's all. But
that's fine. Thank you, Mark.
No problem. You're welcome.